Hello again and welcome back to our course on Excel 2019 Advanced. In this section, we're going to take a look at lookup and reference functions, and in particular, we're going to start looking at lookup functions. Now, as the name implies, what we're doing with a lookup function is looking up a value in some kind of index or list and using the returned or identified value. Now I'm going to demonstrate first a very simple lookup function, which is the choose function. It really is quite limited in what you can do, but you may come across situations where it does the job for you. Now, by the way of a very straightforward example, let's suppose that I have some responses to some survey types of questions, and the people give a numeric response in the range of 1 to 5, and each of those numbers corresponds to a phrase. And in a particular situation, I not only want to show the response as a number, but the particular phrase it's equivalent to. Now, the way I can do that in this case is I'm going to put my phrases in column D. And I can accomplish that by using the choose function. Now I can either start to type equals choose, or I could go to the lookup and reference functions and select the choose function from there. And the first argument is the index number. So this is the number that we're going to look at and use as the basis of our choice. Now for D3, the number I'm going to be looking at is the number in C3. The next argument is the value I'm going to put into D3 if the value in C3 is 1, and we must always start at 1. So I'm going to say that 1 corresponds to strongly agree. Now I put in the next value. A value of 2 corresponds to agree. A value of 3 corresponds to neither agree or disagree. A value of 4, disagree. And a value of 5, strongly disagree. Now I can put up to 2,504 values there. So at the moment I've put in 5 values, which means in this case I can accommodate numerical values in C3 from 1 to 5. Now anytime there is nothing there, I'm going to get an error message. So in this case, hash value. Let me put a number into C3, so let's try 2. And now it says agree. Let's change it to 4. And we get disagree. Now as you can see, that's pretty straightforward. Now choose always works with positive integer values starting with 1 on a continuous scale. In fact, in the response there, if I put something like 3.6, what Excel 2019 does is round that down, and it will give me the equivalent of if I'd put 3 in there. And if it comes out below 1, so if I'd put, say, 0.8, I'd get an error. At the same time, if I put a value outside of the range that we've specified, so 6, I'll also get an error. So that's basically how the choose function works, but it also presents us with another issue. If I'm setting up something like this, is there a way to avoid getting error values like the one you can see on the screen? Now, there are a couple of very good ways that you can deal with situations like this one. For example, you want to put a formula into several cells, but you know that until some other cells have some values in them, that the formula is actually going to return an error. So for instance, you could actually test to see if the response was in the range 1 to 5, and if it isn't, you could prompt the user to enter a value of 1 to 5. But the easiest way of dealing with this is to use the if error function. So let's add into our formula if error. Now with the if error function, what I would do in this case is evaluate my formula using choose, and if there is no error, I will get the value that choose is going to deliver to me. But if I do get an error, what I do is the second argument in the if error function. Note that there's a screen tip there. And I can say here what I would like to appear in D3 if there is an error. Now I might want to put a message in there, such as response must be in the range of 1 to 5. Or if I'm anticipating that I'm going to fill D3 down to D12 with this formula, and therefore I'm going to get that message everywhere, I might just choose to leave column D empty. So I could use a blank, which is what I'm going to do in this case. So we're going to say quote mark, space, quote mark, close parentheses. So now if I do get an error, there's going to be nothing in the cell. Let's see if that works. And you can see there I have 6 as my response, but that's outside of our range. But instead of getting an error, I now have a blank. What happens if I copy that formula down? Let's double click and I get nothing. Let's put a 3 in here and maybe a 1 and also a 0. And you can see that that's working nicely. Now, as I say, you might want to combine this with a more complex arrangement whereby you say, if in fact there is a response in column C, but it's not in the range of 1 to 5, you might want it to say to the user that you must enter a value in the range of 1 to 5. And you can just add that onto the end there instead of having just the quote mark space quote mark. But as you can probably tell, you can build this up to be as complex as you want it to be. So to quickly run over that again, looking at D4, note the use of the choose function there. My index value is my value in C4, and the choose function will return values for an index value of 1, 2, 3, 4, up to the number of alternative values I've specified. The 5 options I have are all text values, but I could have had numbers in there, I could have put cell references, I could have put functions, formulas, names. There are many possibilities of what you can put in. Now next we're going to look at one of the most popular lookup functions, and actually it's a pair of functions, HLOOKUP and VLOOKUP. And in this section we're going to look at HLOOKUP or horizontal lookup, and then in the next session we're going to look at a more complex example of VLOOKUP or vertical lookup. So what we have here are some scores in a quiz, and I have scores for around 20 students. And what I want to do is determine which quartile each student's score puts them in. Now, the lowest score in this list is for Parker Hector, who's down here in row 12, and he has a score of 43. We've got some very high scores in there as well. We have a 98 and so on. So what I'm going to do is use a very straightforward statistical function to calculate the quartiles. Now, let me explain to you first what quartiles are. If you have a set of results like this, think of it as slicing them up into 4 even bits. So I actually have 19 students, but let's call it 20 roughly. You're going to say what range of scores covers the first 5, then the next 5, then the next 5, and so on. So you're really dividing the class up into 4 quarters. Now the first thing I need to do here is evaluate the quartiles. There are values that divide my results into 4 even sets. Now if you've not used the quartile function before, let me just demonstrate something I mentioned on earlier in the course. You might need a statistical function, but you're not sure which function it is. So you might start to type in something like quartile. And look, there is a whole set of them. The first 2 are effectively the same. Quartile is the original quartile function, and quartile.inc replaces it because there is a distinction between quartile.inc and quartile.exe. Now, I'm not going to go into that too much, and there is a distinction between the two, and it's an important distinction, and it really has to do with the use to which the quartile is being put. But for the purpose of demonstrating lookup functions, we're going to stick with quartile.inc. And we have 2 arguments. Which array of numbers are we going to find the quartile of? So in this case, it's B2 to B20. And I want the first quartile. So this will be the score below which the first quarter of students would be positioned. So this is, if you like, the weakest quarter of the class. and I find that that score is 72.5. Now what I need to be able to do is evaluate the other quartiles, and I'm going to arrange them horizontally. And if I select the 3 cells to the right and use the Ctrl+R keyboard shortcut, I get errors. And the reason I get an error is because if I look at the formula in G2, I'm now looking at the scores in C2 to C20, which is definitely wrong. So of course, when I specify the array from which the quartile scores are going to be calculated, I need to use absolute references. So let me go in and do that. Now I can right fill, and of course I will get the first quartile in all of those cells. But all I really have to do is go back and edit those to get the second and subsequent quartiles. And very importantly, at the beginning of my set of scores is the score of 0. Now the function we're going to use in order to decide which quartile each score is in is the HLOOKUP function. And the way that the HLOOKUP function will work is that I will tell it where the list is, and for each student's score, so let's start with John Beale, who has a score of 82, it will read along that list horizontally, and it will basically compare 82 to each of these figures. So it will say, is 82 bigger than 0? Yes. Is 82 bigger than that? Yes. Is 82 bigger than 76? Yes. And then, oh no, I'm not bigger than 87. And therefore the score of 76 in this case denotes the start of the third quartile. The score of 72.5 denotes the start of the second quartile, and 0 denotes the start of the first quartile. So obviously that means 87 denotes the fourth quartile, and 98 is the highest score. The highest score is also going to be in the fourth quartile as well. So basically, as HLOOKUP works its way along there, it waits until it gets to a score that is too big. In this case, 87, and says, okay, well, John must be in the category that begins with the score of 76. And in this case, that's the third quartile. So we're all set to work out our quartiles using the HLOOKUP function. The first argument is the value we're going to look up. So the value is B2. The table array that we're going to look in is E2 to I3. Now remember there, we need to make these absolute as we're going to fill down. The row index number, this is which row gives us the value we want. So in this case, it's the second row. We want it to tell us which quartile these values are in. So the row number is 2. If we wanted to match the values exactly, so if we were looking for exactly 72.5 or exactly 76, we would set the range lookup to false, but we want it to be true. And click on OK. And it correctly says that John Beale is in quartile 3. Let's do a fill down now and see what we get for those other scores. And yep, I think those all look to be correct. I suggest that you check those for yourself, and I will see you in the next section.